1.03 data type. Just listen. We did some code examples, getting input from the user, etc. Outputting information to the screen and some calculations. How the word mass comes into effect in programming. Today we are going to continue from this 14.03 data type. Every programming language has built-in data types. You know about them already. This table gives a subset of those available. The number of bytes of memory allocated to a variable of the given type is given in brackets for VBNet and Java, not for Python. For these two, there are sizes also allocated when the data type is, when a variable is declared. So the description of data is whole signed numbers, which is an integer. In pseudocode, this is how you write, and in Python, int. Signed numbers with a decimal point, real in pseudocode, and float in Python. A single character, we used to say cha, and Python it's not available. You have to use the string for that also, one character also. And the sequence of characters is a string. Both are the same type. str. str is the term used like int for integer, float for real. This is for string, it's str, stored as ASCII, but Unicode strings are also available. Use single quote, double, or triple, or triple single, right? Use single quote mark like this, or double, or triple single, or triple quotation marks to delimit a string. So all these ways are possible. Then logical values, true and false. It's called Boolean in pseudocode, and in Python, it's bool. Possible values, true and false. In Python, a single character is represented as a string of length 1. Okay? Each character, the length is 1. Date has various internal representations, but is output in conventional format. So description of data is date value. Pseudocode is date. Python, use the datetime class. There is a class for that. You can't use, you simply use the date function without calling for the or importing this class. In Python and Java, data is provided as a class. Of course, VBNet, of course, has a different way of storing. There are many more data types. Programmers can also design and declare their own data types. That will come in detail in the next section and chapter 26. Sorry, not next section. Now this is, we are doing 14. So in 16, you will get more, but we'll be doing only 15 for A's. Then there's a task. Look at the identify table in chapter 12, tables 12.02 and 12.04 to 12.12. Decide which data type from your language is appropriate for each variable listed. It's very easy. I have copied those from chapter 12, otherwise it's difficult to go back and forth, scroll up and down. It's difficult. Mm, oh, I have not. I took 12.11, table 12.11, so that you can answer. The question is, look at the identify table. Decide which data type from your language is appropriate for each variable listed. So let's look at the table. Is a table and number of rows. Stores the number of rows and be a real. It has to be, it can't be float rather, because you have to answer in your own uh, programming language. It's not float. It has to be integer, int, because number of rows can't be a decimal point. Number of columns, integer. Symbol stores the chosen character symbol. So whether it's asterisk or hash mark or whatever, then it has to be uh, not char, because in Python it's string, str. Then row counter also has to be integer. Column count also integer. There are no decimal points, so no rush float coming in. Write program code to implement the pseudocode from worked example 12.01 in chapter 12. Worked example 12.01 in chapter 12. So let's have a look at the worked example 12.01 using input output. Write the problem, the problem to be solved. Convert the distance in miles and output the equivalent distance in kilometers. So you input the number of miles, calculate and output the number of kilometers. So let's take a new file. So we need two identifiers at least, or two, but two will be enough, or else we might need another one for the answer. Either two or three. Let's try both methods. Two identifiers, what? Miles and kilometers. Miles has to be input. We have it as a integer, not as a float. Integer input. Integer input. And let's have a prompt. Enter miles. Now we have the input, number of miles. Now we have to calculate. What is the calculation? Kilometers. Let's have K equals miles multiplying the number of miles by 1.61. Miles multiply 1.61. Okay. So kilometers will be a float. So this is an integer input. Once you calculate because of these decimal points, kilometer will be automatically a float. You don't need third one. It's not a case of totaling or any other accumulation. So this is simply the answer to your output. And can say miles. Miles, comma, then again say miles as a constant images. Well, let's add that as a variable. Kilometers. So many miles equals so many kilometers. So some taxi. Ask, ask 14.02. Not done. Zero, two. Run it. It will ask for miles. The mile is a 10. And 10 miles equals 16.1 kilometers. Value, let's check one whether it's correct. Yes, 1.61 kilometers. And one last time we'll see like 5 kilometers. 5 miles will be 8.05 kilometers. So that's done. Then we come to Boolean expressions. In chapter 12, we covered logic statements. These were statements that included a condition. Conditions are also known as Boolean expressions and evaluate to either true or false. True and false are known as Boolean values. Simple Boolean expressions involve comparison operators. Here are the comparison operators. Complex Boolean expressions also involve Boolean operators. That's the next table we will have. So the usual normal comparators are equal, Python, double. This is not for assignment. This is not the assignment statement. This is the uh, compare, comparison operators. Simple Boolean expression involve comparison operators, right? So these are comparison operators. For to check whether it's equal, then double equal sign. Not equal, this exclamation and equal, greater than, less than, greater than or equal to, less than or equal to. You know all those things. Then Boolean operators and or not. Same. Or not. The Python. Then we come if then statements. In pseudocode, the if-then construct is written as if some Boolean expression, which is a condition. If that expression is true, then do this, and if. Syntax definition, Python, if Boolean expression, colon, statements. For this pseudocode example, see how the Python. If x is less than 0, then output negative, ending. If x less than 0, colon, print negative. No ending. Task 14.03, write program code to implement the pseudocode from worked example. 12.03 in chapter 12. So let's go back to 12.03. See, worked example, yeah, worked example 12.03. Twelve point zero three, using selection constructs alternative method. The problem we solve, take three numbers as input and output the largest number. This is an alternative method to worked example 12.02. In 12.02, feed it. This is greater than that and the other. Then this is the, if the first number is greater than second number and also third number, then first number is greater. If the second number is greater than the first and the third, then second number is greater, like that. But this is a different method. Input the first number and store it in a bigger sofa. Input the second number and compare it with the value in bigger sofa. If the second number is bigger, assign its value to bigger sofa. That means update the bigger sofa. If the next number input is bigger than the bigger sofa, update it. That this is the biggest. Input the third number and compare it with the value in bigger sofa. If the third number is bigger, assign its value to bigger sofa. The value stored in bigger sofa is output. The identifiers bigger sofa and next number. Only two variables. The earlier one, we took n1, n2, n3, three variables. Task 14.03. Well, so let's do it. Good example in 14.03. Okay, that is this. And let's take the Python program and save it as variable name. It's easy then. Each word begins with a capital letter. Equals. This also will assume that it's the user is not going to enter decimal points. So integer input. Then we check if next number is here. Now there's one already input. We are taking it as the biggest so far. Now we check whether the next number input is bigger than that. If so far becomes next number. We'll replace the biggest so far with next number if the next number is bigger than the biggest so far. Then again, same. Then input next number. So the third number will be input, and if that is uh, greater than the biggest so far, then that will replace the biggest so far. And then finally, output biggest so far. Variable, no description. Name given. So enter number. Say 1, 2, 3. 1, 2, 3 is the biggest number. This time we'll enter 2, 1, 3. Three, 1, 2. A few more. 3, 1, 2. Then also is 3. So we can take it as correct. Then we are adding else to it. If then earlier. Now if then else. If this condition is true, then this will fall, then that. Syntax is if condition is true, there's colon there and then statements, else, colon, and statement. So for this pseudocode sample, if we'll do that and read it. And the Python code is given. So let's take it. Run it, then there's bound to be an error. What is the error? Think about it. Name error. Name X is not defined. So they're saying if X is less than no value. We have to give a value and we are calling it initialization. Initial value. X equals 10. Positive. 10 is positive. Let's give a minus 10. Gives negative. So x equals minus 10. If x is less than 0, so you have to translate. X is minus 10. Minus 10 is less than 0. You have to decide whether it's true or not. Minus 10 is less than 0. It's true. Then you have to do this and not that. Print negative. Then we have nested if statements. Pseudocode, if Boolean expression is true, then this, else, if it is false, then we check for another condition. If Boolean, when this is false, whether this is true. Boolean expression is true, then this happens. That is also false, then this happens. So there are statements 1 set, 2, and 3. But only one will happen. Either this, that, or this. Only one path will be taken. That's only the syntax. Not else if. In the pseudocode, it was else and we were checking another if. But you could have said else if combined. So let's see that's how it is done here, elif, not else if, elif. That's a Python. Then else and finish off. So, yes. If Einstein, if x is less than 0 is negative. Elif, if x equals 0, print 0, else print positive. Let's try with this first. Minus figure. It says negative. And let's change to 0. It says 0. And finally, let's change it to 50 and positive. Yeah, it says positive. Fourteen point zero four, write program code to implement the pseudo code from worked example 12.02 in chapter 12. So it's worked example 12.02. So, and now we are going back to the easy method, earlier one. It is greater than 2 and greater than 3. Then output number 1, output number 3, like that. So let's take this and change it in Python. We can save some time there. Point zero four. Just to double check the number. Yeah, class 14.04. Now let's start changing. Number 1 equals integer. Assume that they are not real, not float. Integer, import, and a little bit of description. Should be numbers are there. If capital can't be, it has to be simple. If number 1 is greater than number 2 and a colon, no need of them. Of course, you have to indent. And nested. And the is hash sign. Number 1 is bigger. If number 1 is greater than number 2, that means number 1 is bigger. Then if number 1 is greater than, again if has to be simple. Number 1 greater than number 3, polar. If number 1 is also greater than number 3, print print brackets. Now in the commas, it's a variable. Print number 1. That's the biggest. Now else. So else we can have it the same. Indentation. Else If the if one is greater than two, but not greater than three means then three is greater. No? And number three. Now this cells, where does it belong? Here. No? This is if number one is not greater than number two, then we are then that means number two is bigger. We would have put elif also, but since the book has given like it, this we will carry on like that. Else, if number two is greater than number three, we have missed something. No? Is greater than one and number. If number two is greater than number one, and we can also combine, right? One. Again, you have to take if number two is greater than number three. Yeah. Number two is greater than number three. Two is greater than one and greater than three, then output else. This else is no, it has to be here under that. Else, if none of those is right, then print number three. No need of n gives. I have a feeling that it's not right. Uh, we did it, we did it in a hurry, but let's try that and see. Otherwise, when you are doing, you can correct it. Reminding, you have to do this. My doing will not help you in any way. or without even you need not do the same way that the book has given. It's a little bit misleading. And if number one is greater than number two, in that case, number three, then you can stop it. Yeah, one of them only wrong. We can test it out by doing. So this has to be one, three. Yeah, number three. Number three is bigger in this case. Let's see. Three, one, two. So it gives correctly, right? Three. So likewise, there are certain things correct. Only one particular thing is not correct. So yeah, instead of my spending time here, better you do it. And two also can check. Two, one, three. No, that's also wrong because the logic we have to check properly, then see. Otherwise, there's a different way in which you have to learn those things. Now, I will do that and show you how you combine. So it's a shortcut. If number one is greater than number two, and elegant way, short and elegant. Number three, then print number one. Number two. Number two is greater than number one, and number two is greater than number three. Then print number two. Then the third number. Sorry. If number three is bigger than number one and is bigger than number two also. Then now put number three. So that's simple. This is a composite condition, but simple logic, easy to read and easy to see. Then we come to case statements, similar to if then, a collection of if statements. An alternative selection construct is a case statement. Each considered case condition can be a single value separated by commas, a range, or a range. In pseudocode, the case statement is written as case of expression. So, condition is here. Case of these are pseudocode keywords, so you can't change them. They have to be same. Only here, this your condition can change. Either variable mm, uh, Boolean expression or um, identifier to see whether the value of that, the value, if the value of that is something here for the value 1, then these statements for value 2, comma 3, that is single value is this value 1 and single values separated by commas is this value 2, comma value 3. For those, if they are matching this condition, then this one, or else value 4, value 5, say like 5 to 10. In this case, it can be like 10. Then this one, 3, comma 7, two values. This one can be 3, 4, 5, 6, 3 to 6. Right? This value to that value. Then also some other statements. The colon is essential. Colon is essential for the syntax. Finally, you have something called otherwise, like else. The in if then else, you have if this is true, they do this. Otherwise, else. So here it is called otherwise. That's also a keyword, so remember you can't change it. And whatever the instruction is here. An end case, like end and end if, here case and end case. The value of expression determines which statements are executed. So depending on this, it will lead to whatever the block of statements there. There can be as many separate cases as required. So you can have many like this. The otherwise clause is optional and useful to for error trapping, validations and all that. Otherwise, it's not essential. It's optional. In Python does not have a case statement. You need to use nested if statements instead. So in Python, you don't have case. Here's an example. Pseudocode. Case of grade. So this is an identifier. If the grade is A, then output top grade. If it is F or U, output fail. If B to E. See, now this is single value A. These are two values or more than one separated by a comma. Here it's a range B to E, B, C, D, E. Otherwise, output invalid grade. So if you put Z or something, then invalid grade. So the coding is but how to do this. It's sufficient to look at grade equals A. There's no case, remember. They're just using if to simulate case. If grade equals A, then print top grade. And if grade equals F or grade equals U. So that our requirement is this, no, either F or U. This command can be like or. F or grade equals U, then print fail. If grade in, see, this is like you have a, I want to show you another technique now. We make a list. List equals A, B, C, then if I normally we say, normally what do you say? We say rain, no? For A in list. Mm, B for butter. And C for cheese. For the letters that we have A, B, C. And 5%. So it will come. A for apple, B for butter, C for cheese. Why is this? Because A like a range, it's if I just put now let's see, I'll do the same thing. Now, these three different ones. I'm going to just put print A, simple A. Why? Because I'm saying for A in list. Just change it now. Make it what will happen? What do you expect? What do you expect? Now it is N in list means A for first time N will become A. Second time N will become B. Third time N will become C. So this N will, the value of N will be printed. Time it's A. If we change this, from this, we get different list. Let's check the values of my butter cheese. We do this for N in this. For N in this, print N. The N will get these values. First, N will become apple. Second time, N will become butter. Third time, it will become cheese. Just like in range, you have 0, it will become 0, 1, 2, 3, goes on. Here, these will come. Not in range, but in list. So it's important to note that. So here it is, what it's doing is grade in. Here is checking grade, if grade equals F or grade equals U. But here Grade in first time it will be B or C or D or E. So any one of them. Then sparse. Print invalid grade. So let's do it anyway. For case if grade equal maybe sometimes you might have to change these inverted commas. Let's see. Yeah, name grade is not defined. We have to like either input or define at the beginning. A sorry grade equals what? We will change it. We change it to D. Yeah, it's passed. Then we have to check only this one. No, no, sorry. Yeah, so it worked. B, C, D, or E will be passed. Then fail F for U. So let's put it. F. Class 14.05. The problem to be solved. The user enters the number of the month and year. The output is the number of days in that month. Program has to check if the year is a leap year or February. The pseudocode solution is input month number. So there's one input, then another input year. And this is not the input, we are just initializing days equals 0. Case of month number, case 1, 3, 5, 7, 8, 10, 12. If these are the ones, 1, 3, 5, 7, then days equals 31. That is January, March, May, July, August, October, and December. Those are 31 days. No? So case 4, 6, that April, June, September, and November, those are 30 days. And if 2, that is February, 28. But if year, now in this case, this will work under this. Under case 2 only, this will happen. If year mod 400, that means year divided by 400. And if there is a if there is no remainder, that means every 400 years this should happen. Every 400 years. Then it is a leap year. And day is 29. That is one way. Another way is if year mod 4, this is the method that you know. You may not have known about this method. Every 400 years also you have to add. You know the calculation, you know how the leap year comes. So 365 and a quarter. Quarter days is the real cycle. So every 4 years, the 4 quarters will give another day. And it's not really exactly quarter. There's another approximation. So when 400 years go, another day is accumulated. So this is the normal here, not 4. That is, if you can divide by 4, that's also. But at the same time, here what 100, you have to divide. You can divide by 100, and if no remainder, or sorry, greater than 0, that means there is a remainder, then it is a leap year. So that is another way. Days, in all these cases, either 400 years or then if you divide by 100 and if it is more than 0, then there is a remainder. And if you divide by 4 and there is no remainder, then also it's 29. Otherwise, output invalid month number. So if you don't have 1, 2, 3, 4 up to 12, you have 13, 14 or something, then otherwise invalid month. In case output days. Output days, we are calculating the days here. No? Days equals 30. Days equals 31. Here days equal 29. All right, program code to implement the pseudocode. So, number is input, and then here days equals 0. Then these are the numbers, the 21, January, March, May. This is the other one. And then if month equals 2, then days equals 28. That's normal way. These don't take place, then it will be 28. But if this happens, any of these things happen, then it will be 29. Else print invalid month. Print days. Number of days. Let's try month number. Let's try January. Enter year. Any year. 2023. Valid. Then enter year must be, let's check. I didn't check the code. If month number equals 1 or days equal 31. This won't happen, this won't happen. Why did it say else? Yeah, this is, it has to be maybe 30. I have to finish it here. Now let's see. 1, 2023. Yeah, it's okay. 2023, January is okay. Let's check the February one. Or let's check another 30 days one. June 6 and 2023. Yeah, 30 days. January 31 days, June 30 days. Then let's check for February 2, 2023, this year. invalid month number. Is the problem here. There's otherwise is not there here. So you have to be careful. If we have to do it in a different way. Yeah. Otherwise, it's a built-in part of the case statement. But since there is no construct like that, we have to check if n 0 or n. And both can't be true. What is less than 0 can't be greater than 12. Actually, this should be 1. Greater than 12. Simple change there. And then print number of days. There has to be else. No? Else print number of days. uh, 2000, the year 2000, 29 days. And divided by 4, that is divisible by 400 also. 2000 and 2024 is divisible. 2024. 2, 2024. Since it's not a construct case, there's no case construct here, you can't use the otherwise clause the same way that we use in this tennis. Here we are going through all these things, then we have to check separately. Otherwise, we have to see if, elif. You can do that. First if, then elif. Here also elif. Here also. Here, of course, you can have if and then else. Right. So that is done. So it looks big. Can be done easily. Then we come to iteration. Already know three types. Three types. Condition loop, two types. One is pre-condition and the other one is post-condition. You must have these things at the tip of your tongue, right? Must come automatically by now, right? So count control is for loop. Let's see the for control variable in range or in range SEI. But if you just put one, you will know that you don't have to specify those two. It will be 0 to that number. For x equals 1 to 5, output text that will be 1, 2, 3, 4, 5. For x equals 2 to 14, step 3. This is the third parameter. Step 3. And step is a keyword in pseudocode. What's the increment? So 2 to 14, 3 and output text will be how much? First time, x will be 2. It will be 2. Then the next time, 3 will be added 5. Then again, so 2, 5, 8, and 11. And 14. In Python, yeah, in pseudocode, yes, 14 also. But in Python, the 14 will not come. You have to put 15 if you want 14. The code example, yeah. We have done enough of these things. But nevertheless, I'll do it. In the idle, for x in range 5, print x, and this end equals this. Hope you remember. That is to print on the same line. Yeah. And since we didn't specify the start, it is printing from 0 to 4. Shall we now do the starting number 1, 1, 2, 3, 4. As I told you, 5 will not be printed. So on 5, then let us put 6 here. Now let's try the third parameter. One, 3, 2 is getting added. 1, 3, 5, 7, 9. And also, the last time I'll do another one. Now, that is 10, 2, 1. Then let's put minus here. Counting down, starting from 10, minus 2, 8, 6, 4, 2. They also has given these different count down. Here's the other one. X in, not range, but this X in or list, either list. If you have created this as a list, then you can say list, the same spellings, variable, or else straight away you can put like this, ABC. Program code to implement this with the code from web example 0.05 in chapter 12. Write program code to implement the code from web example 0.08. Write program code to implement 12.09 in chapter 12. And I think you better do those. I'll put them as homework. Otherwise, we will not get the knowledge. You have to do all the tasks. Yeah. Especially this, since I didn't do it. Then post condition loops. So the condition loop, one is post condition, the other one is precondition. Post condition, as I have repeatedly told earlier, it's checking at the end. But that is not there in Python. Post condition loops are not available in Python. Use a precondition loop instead. So repeat until is In pseudocode, repeat until is a 1 that you have. Language in Pascal language, of course, you have the same thing. Repeat until in the same format you have. Of course, the semicolons and all that, those things come in Pascal. It's a different matter, but the syntax, the format is, the construct is the same. So, post condition, you can't. 1407, write program code to implement the pseudocode from work example 2.3. Yeah. So these also can do. In the precondition loops, that is, you can use as while. While condition is true, do these statements. Not if is different, it's only once. If the condition is true, do these steps. But here, the condition is true, do it until the condition changes, becomes false. So the Python, the syntax is while condition is true, repeat these statements. And a pseudocode example is answer equals blank. While answer not equal to y, you input enter yes or no. And the in pseudocode sometimes they write like this also. Prompt and the variable on the same line. This textbook also uses both methods. They are not uniform. Some places they have, or here they use only this method, I think. Yeah, that's right. Yeah. But this is also okay. Otherwise, you output the prompt first and then input the variable. So let's see this answer. It also can be done in the there. Enter y or n. Okay. So answer we have at the moment we have put blank. So is blank equal to y or is blank not equal to y? Yes. Blank is not, this exclamation mark and the equal sign is not equal. So answer is empty, empty string, not equal to y is true. Then do this. Do this until answer becomes true. That means anything other than y. I'm sorry. When you enter y, then this becomes false. The y not equal to y is wrong. The statement y is not equal to y is false. Then we have to stop this. So let's put n first. Then we put y, simple y. That also won't take. We have to put capital Y because we are checking for this. Only capital Y there. When I put capital Y, only it will end. So that's a loop. Precondition, checking first. Then there's a task. Write program code to implement the second algorithm from worked example 12.06. So put in 0.08 also. Then which loop structure to use? To know how many times around the loop you need to go when the program execution gets to the loop statement, use a count control loop. That is 1 to 10, 1 to 100, you know the number. If the termination of the loop depends on some condition determined by what happens within the loop, then use a conditional loop. You don't know how many times. Huh? This loop, you don't know how many times, so you can't use a count control loop because it will go on until it say yes. A precondition loop has the added benefit that the loop may not be entered at all. The condition. What happens here? If I'm changing now, answer equals y. Why? Because this is not true. Y is equal to y. Not equal to y. Y is equal to answer is equal to y. So this can't start. This condition is false. Right. Computer scientists like efficient code, choosing the most suitable types of selection statement and loop structures is an important step along the way to design efficient code. Right. So that will be enough for today. Then built-in functions, there'll be a whole lot of things. We can do that next time.